Welcome everyone to another session of VQMS. Today we're very excited to have Ilya talk about a topic that is very close to my research interests as well. So talking about the effect of personalized rankings on search and purchase decisions. A couple of housekeeping things before we get started. Panelists, please just unmute yourself whenever you have a question, and for everyone else, please use the Q&A feature. With that, Ilya, you have the floor.
All right, perfect. Thanks a lot for inviting me. Thanks for having me here. So today I'm happy to talk about our new paper. We called it The Long Tail Effect of Personalized Rankings. And this is written in a collaboration with two brilliant co-authors. One is Rob Donnelly, who is here today. He's my former classmate from Stanford and now at Instacart. And the second one is Ayush Kanodia, and he's a PhD he's doing his PhD in computer science at Stanford as well. And so what is this about? Well, let me open with kind of the three basic observations about online retail we started writing this paper with. First of all, the assortments we see on online retail are extremely large. So we routinely see kind of retailers offering thousands of highly differentiated products. Two, it turns out consumers search very little. So most consumers would never compare more than a few options, would never go beyond the first page of search results, and so on and so forth. And three, what you put in front of consumers actually matters quite a bit. And so with all of these things in mind, retailers who realized all of these facts very early started to add some amount of personalization so that they can kind of efficiently guide consumers towards the most important and relevant products. So retailers realized that pretty early on. They started writing and implementing personalization algorithms. And by now we have already accumulated a huge computer science literature on so-called recommender systems, the literature that tries to design new algorithms, improve the existing ones, and use increasingly rich consumer data for those purposes. And that field is very applied, which means virtually all or most retailers are using some versions of these algorithms already. But despite the fact that now these algorithms have been so widespread, we still know very little about how these algorithms, when they implemented in practice, actually affect online markets in long term. And so one specific question we will be asking in this paper is, are these algorithms actually benefiting consumers? Now we know that they're benefiting retailers, otherwise they would not use them very often. But is any of this actually good for consumers? Now, what do we know so far? Well, I like to start by discussing kind of a seminal book of Chris Anderson on the long tail effect, where Chris Anderson basically pointed out a conjecture, and he said, personalization must be very good for consumers, because what it does is basically it allows to match people with relatively unusual preferences to relevant niche products, right? And so that's going to create a lot of surplus. That's going to create the long tail of products that can now be discovered, whereas without personalization, they are very difficult to discover, and that's very positive thing for consumers. Now, a lot of people talked about that conjecture, but few tested it. One paper that I want to refer to here is Holtz et al., a recent paper on the Spotify streaming recommendations that used the field experiment to show that once people get access to personalized recommendations on Spotify, they start listening to a much larger variety of music. In their case, I think it was podcasts. And the market share of quote unquote niche items in that market increases quite a bit from personalization. Now, that's broadly consistent with what Chris Anderson had in mind, except Lee and Hasanagar wrote another paper, this time on online retail, where they also used the field experiment, and they showed basically the opposite effects, which is once consumers get access to personalized recommendations, the market share of niche products actually goes down and the market becomes more concentrated. And so the fact that we have mixed evidence from these papers is interesting to start with, and it warrants further research. But the question that we think is kind of really missing from this literature is any of this good for consumers? Some sort of a welfare statements regarding the effects of personalization. Yes, Chris, you had a question?
Yeah, hi. Can you speak to maybe any assumptions you're making around like the objective of the personalized recommendation? So are we assuming that the firm is trying to maximize the engagement in some way, like the number of clicks, or are they a profit maximizing firm? And maybe you can speak to that both with like this literature review and also to, you know, what we should have in mind going through your talk for your research.
That's a perfect segue for the second part of this slide, where essentially we offer some thoughts on what goes into these personalization algorithms. So on one hand, we have this opinion of basically Chris Anderson. It's not an opinion, it's a hypothesis that this is great for consumers because if retailers are thinking about consumers when personalizing, that's got to be good for welfare, for consumer welfare. On the other hand, we have accumulated plenty of evidence that a lot of companies are trying to tweak personalization algorithms in a way that's more aligned with their profit optimization rather than them guiding consumers towards high utility items. I just give you a few examples. I will not spend too much time on that, but Amazon back in the day used to send email recommendations of products, and they have been revealed to put a lot of weight on how profitable these recommendations are, as opposed to how likely they are to convert people into buyers. Netflix tweaks its recommendation algorithm, used to tweak, and probably they still do, in order to emphasize their own in-house produced movies that are kind of easier and cheaper for them to stream. And Pandora is famous for their steering experiments that try to, it's been revealed that they routinely experimented with steering consumers towards items that are not, towards music that's not necessarily that's not necessarily popular, not necessarily good for consumers, but to music that they actually own and that's cheaper for them to show. And so, all of this is anecdotal evidence, but we think that what it's showing us is the fact that a lot of companies who are trying to use these algorithms are thinking about that additional profitability metric. And to the extent that in doing so, they can steer consumers towards quote unquote wrong directions, that may actually reduce consumer surplus. And so the global question we will be asking in this paper is, A, is that good or bad for consumers, that there is personalization? Kind of on average, is the effect positive or negative? And B, if we have established the sign of that effect, well, just how large that effect is, right? If it benefits consumers, how much surplus is it actually creating? So what do we do in this paper? We do two main things. One is we're going to show you the results of a field experiment where some random selection of consumers sees personalized rankings. By personalized rankings, I will mean the way products are ordered in the product category. And the remaining consumers will see non-personalized rankings. And we will start by showing you how that experiment reveals that personalization has quite large effects on what people choose on the platform, on the website. And in the second part of the paper, we want to get to that welfare question that we think is very interesting. For that, we are going to estimate an empirical choice model. And basically, the goal of that model will be to infer a heterogeneity of consumer tastes and infer, which consumers like which products. And we're going to do so from two sources of data, from search data and from rankings. From search data, because we kind of want to look at what products you are clicking on and with what attributes. And that will tell us something about what you're looking for on the website. And the second source of information we're going to use is personalized rankings that you actually see on the platform, with the idea that the retailer has already learned quite a bit about your preferences. And so the rankings he shows you are actually partly informative about what is it you are looking for. Or as we usually express it, tell me what your Netflix recommendations show, and I'll tell you who you are. And now, once we kind of have all these pieces in place and we have learned taste heterogeneity, we're going to compute the surplus of the same consumer with and without personalization and make welfare statements. And as a quick preview of what we are getting out of it, three main results. I'm going to preview them quickly and I will tell you details later. One is that the experiment shows that personalized rankings tend to have quite large effects on behavior. They make people more active, they click more, consumers click more, consumers buy more. More importantly, they buy a much larger variety of products. 2, it seems to be good for both consumers and the retailer. The retailer actually increases his revenues by 4.5%. The average consumer increases his surplus by about 30%. And most of this effect, as we find, is driven by the fact that people or consumers with relatively quote unquote unusual preferences can now much more efficiently find items that are a good match for their specific tastes. Okay, and finally, we show some back of the envelope calculations that personalization is what allows the retailer to offer large assortments in the first place. For example, when we shut down personalization and we say what would have happened had if in the world where retailer could not personalize at all, well, we find that the assortments would have been 4 times smaller. Or in other words, personalization is what allows our retailer to offer 4 times more items according to those results. Let me pause here and see if there are any questions. Yes, Chris?
Yeah, sorry, it's related to my last one for your work in particular, because I didn't quite follow. So if you can go back to the previous slide, and I can be maybe more specific on my question. So can you be clear as to what the objective was for the retailers, like optimization or personalized recommendations? So for instance, did it incorporate kind of showing customers diverse sets of products? Because if so, then obviously you would have number 2 or the second bullet under number 1, where they buy a larger variety of items, but that's simply because, perhaps the retailer is giving a personalized and diverse set of items to the shopper, as opposed to showing just the most popular products. So hopefully that makes sense. But can you speak to maybe the objectives that they're using in this work?
So I'll give you a short answer, and if that's okay, I discuss a long answer in 3 slides where I'm going to talk about it.
Sure.
The short answer is our specific retailer puts some weights on 2 objectives. One is increasing the probability that the consumer clicks on something and purchases something. Think about that as engagement. And the second objective meaning being a profit optimization, whatever that means, selling items that bring higher markups. We don't know the weights, and we're going to, part of our estimation is going to be, we will try to reverse engineer this weights, if that makes sense. I'll tell you this much now, but more is coming in 3-4 slides. All right, so let me move on and show you the context. So for this paper, we have collaborated with Wayfair.com, a large online retailer of furniture and home improvement goods. We got data from them for 2 months for the period of 2 months, from September to November 2019. We narrowed it down to the category of beds. Now, the choice of that category is driven by the fact that it's a very large one. It's a very profitable one for Wayfair, so it's strategically important. And it has a lot of products being offered, so talking about long tail effects there is very meaningful. This is going to be a sample of 1 million users, and the unit of observation here is a visit. So the same user may come back to the website multiple times to the same category of products. We see all of these visits, and for each of these visits, we actually see the quote-unquote environment data, which is everything consumer actually sees, right? Product rankings, prices, basic product attributes, all of that. Search data, which is what the consumer clicked on during his visit, and purchase data, which is what that consumer bought, if anything. The website looks, for those of you who have not seen the website, it looks pretty standard. When you go to the category of beds, you see the list of products. So this is the list that will be personalized in the experiment. You click on one of the items, that sends you to the product page with the detailed description of a product, some textual information, and customer reviews. So this is all really standard. What's less standard is the fact that we have data from an experiment that was conducted on this platform. In the experiment, people were randomly assigned to 2 groups. 95% of consumers were assigned to the personalized group, where they see rankings generated by a collaborative filtering personalization algorithm. And the remaining 5% were assigned to a holdout group, or think about that as a control group, where they all see bestseller-based rankings. So everyone sees pretty much the same ranking, and it's based on the historical popularity of items. So bestsellers at the top. Now, and this is back to Chris's question. In the personalized group, what Wayfair is doing is basically they implementing some version of a collaborative filtering algorithm that's kind of inherently designed to send consumers to different directions and show them a pretty large variety of items. But they are using a modified version of this algorithm that also accounts for their other objectives, such as profit optimization. And once again, we don't know exactly how much weight they are putting in all of these things. And part of our model is going to be to try to quote unquote reverse engineer their objective function. And based on that, tell whether their incentives are aligned with the incentives of consumers that are looking for products in this context. So that's the experiment. We think that this experiment is interesting, not only because it actually randomized exposure to personalized rankings, but also because the comparison it's making is a very common one. On one hand, we have a personalization algorithm that's based on a collaborative filtering structure, and that's a very common set of algorithms to consider. On the other hand, we have this benchmark of people seeing bestsellers at the top, which is also a very common default algorithm that you see in online retail. And to the extent that this experiment is capturing this trade-off between these rankings, we think that it will have some external validity.
Ilya,
now, we were worried.
There's a question from the audience. So to what extent are users first-time users? Like, what kind of information is a personalized ranking kind of using? How many of these guys have visited Wayfair a lot before, and what kind of data is tracked about them, I guess?
So you need to know two things about the algorithm in response to that question. One is it learns from your past behavior within the category as well as in other categories, right? So if you are browsing couches in the past and now you're starting to browse beds, then whatever you browsed in the category of couches will affect your personalized rankings in the category of beds. Obviously, if you have browsed the category of beds already in the past, that's going to go into that algorithm as well. And so in general, the algorithm is trying to kind of efficiently learn from all that information and predict what is it that you're looking for. Now, for new users specifically, Wayfair doesn't have much data. If they have not browsed in other categories and in this category, all you know about them are some basic demographics that don't give you much, or don't give you much scope for personalization. And so these users are going to see basically the same rankings that they would have seen in the holdout group, right? So they would just see bestsellers at the top. Most people in our data have some prior exposure to the website, in the sense that we do see their rankings are personalized, but it's important to consider that not all people who are assigned to the personalized group will actually see personalized rankings. All right, and so
Ilya, can I quickly clarify here? So,
of course,
do we assume that if there was no profit component for the algorithm, then users will be better off, or is it something you'll be showing us? Because maybe I missed this part, but it seems like personalization doesn't necessarily increase welfare, make consumers better off. It really depends on how a platform implements this. So I wonder if we're learning something about the algorithm, and it's kind of how does the algorithm of personalization, how it weights it versus profit, can you talk a bit more about that?
Yeah, so without the profit component, it would be very difficult to come up with an example where people are worse off. You have to really screw up the personalization algorithm somehow to send them all to wrong products. So in general, without the profit component, we expect consumers to be weakly better off. With the profit optimization component, that's where things get interesting, and that's where we are kind of most interested to study this. And so what we're going to claim is, here we have an implementation of this algorithm that has both of these things, right? They care about consumers, they care about their profits, they put some weights on both things. And what we want to study is kind of what is the net effect. On average, when the algorithm is implemented in a way that caters to these two objectives, what does that do to consumer surplus? Does that answer your question?
Oh, I guess, but I'm not sure I agree with the first kind of conjecture you're making. That easy example anecdotal one is if you shop for substitutes and already purchased a product, the algorithm will be recommending you a lot of the product you already purchased, which you don't need anymore. So it really, it will be helpful to know more about the algorithm and know more like what it's doing to understand if we really expect it to make it better off, or we expect it to show the same product again, like somehow interfere with my search process.
Yeah, so in terms of, yeah, I think I see a point. So in terms of showing the same product as you have already bought or looked at, certainly. I mean, I still don't think that would necessarily decrease consumer surplus. I think what could have happened is you show relevant recommendations, and that's not going to have any effect on your choice. But kind of regardless of that, I think the part that makes it interesting is the fact that the retailer is going to care about profits, and that incentive is not necessarily aligned with the incentive of helping consumers. That's what's going to derail the retailer from showing you all the right products, the right quote unquote. And so that's the part we particularly want to study here. Okay, and so let me actually show you some results of the experiment. Just as a note here, we worried quite a bit about kind of doing randomization checks and dealing with imperfect assignment. We have a lot more about this in the paper, so I'm not going to go into detail here. But one thing you want to know is to make sure we have a clear definition of rankings to which you were exposed in this data sample. We take each consumer and we take the first visit of that consumer within the 2-month period. And for that visit, we take basically the rankings that consumer sees, right? So that's quote unquote the treatment. And we also take all clicks and purchases that consumer made on that visit and after this. Okay, so think about that as kind of us studying the long-term effects of personalized rankings. Yes, Kevin had a question.
Yeah, just a few thoughts. One, I'm not sure if the positive or negative consumer surplus is, I don't think you need to set up the profit, oh, there might be a distortion here. And for the following reason, and I guess I'll say a few questions on this. So you said if you're new to the website and you're in the personalized group, you just get the holdout rankings, right? So like what fraction is that? I assume it's quite high.
It's definitely less than half. I'm not remembering the exact number, but
Okay.
we can look it up later. Mm-hmm.
My next question on this is we're dealing with durable goods, and it's not like I buy beds often, and I'm not really sure my single lamp purchase on Wayfair 2 years ago is really informative for my bed purchase. So I think you should tell us a bit more about what personalization means here. I mean, is personalization, my zip code, so I'm wealthy or not? And so that gets us more towards thinking about the welfare question, I think. And so, I mean, relatedly, like what fraction of products are recommended to me that you never see a sale for? I mean, what's the profit motive there? It's probably more like demand discovery that Wayfair has yet to sell this bed and they want to see if there is demand for it or not. And so I think that's just kind of a different framing and different type of welfare analysis than kind of what you're priming us for. So regardless, I think you should think about these issues. It seems important.
Yeah, no, this is super interesting. So just to give 2 quick answers, there's a lot to unpack there, but so one question there was, what is personalization exactly here? And so I want you to think about that as, last month you were browsing some couches and you were particularly interested to look at orange couches that look very modern. What I learned from you as a retailer is you like modern style furniture and you like color orange by some reason. Maybe it matches the color of your walls. And so when you start to look for armchairs, I kind of know what you're looking for. Not quite, but I learned something from your history. And of course, they're going to downweight the histories that are kind of too far away. So I'm going to downweight what happened 1 year ago in that algorithm. Now, the second part of this question was, what is it that Wayfair is trying to do? Are they trying to sell something that they never sell? I think that's part of the potential story here. So now we are working to add basically a very simple toy example to the model that illustrates very similar to what you just described, which is this situation that there might be a lot of quote unquote niche items on the platform that only match some people's preferences, but most people are completely indifferent to those items. And then the key question there is, what happens when I start matching people to these niches? What happens if I learn something about your preferences for modern style furniture and start showing you very modern looking armchairs? Is that actually good for you? You know, are these niche products going to be very, very good match for you? Is it going to create a lot of surplus? Or are we in a situation where, you know, if I cared about consumers, I would not send them to these niches because the products there are not very high quality, but I'm sending them there anyway because those products tend to generate high markups. Now that's the kind of margin we're thinking about, but it will become a bit more clear once I showed you kind of this long tail effect in action in the next few slides.
Ilya, just something before you show us the next slide, because it might be related. So what happens after someone sees this default ranking that you're showing them? Can they sort? Can they filter? Can they go back? And what happens if they go back? Can they choose? Can someone from the personalized ranking group choose to sort things based on bestseller rankings? You know, that can give us some evidence of how good the ranking was. So how do you treat them also, I guess, in the data?
Yeah, so we treat them in the data as we are taking the first visit you made. We see the rankings that you encountered in that visit, personalized or not. We see exactly what you see on the page. And then what we're going to do is we're going to just take all the clicks and purchases you made after that, and we're going to measure the effect rankings had on those clicks and those purchases. Now, can you look at these rankings, leave and come back and use filtering tools? Absolutely, but we are okay with that. One thing I want to mention here is people who are typing something in the search line, something like, I want an orange couch of modern style, or the kind of people that know exactly what they're looking for, they are not going to be in our data. And so that's one potential limitation of our analysis is we have not incorporated those people, but those might be people who actually know what they're looking for. And so they might be kind of less prone to being affected by personalization and personalized product suggestions. Okay.
Just a clarifying question on that final thing. So doesn't the treatment affect whether you search for an orange bed? I mean, like, how can you just exclude the sample of people that do that search?
Yeah, so think about this way. There might be two types of consumers. One type is a sample of people who already know what they are looking for, and they go there and they filter. They use the filters. They use the search line to narrow down their kind of consideration set to a very small set of products. And then there might be the second set of people who don't know what they are looking for, who are kind of just there saying, I want a bed or I want a couch, and I don't really know what exactly I need. Show me personalized recommendations. Show me the suggestions you have. And so we think that that second group of people is the group of people for whom recommendations are going to be relevant in the first place. And so that's the sample we're restricting it to. But of course, any estimates we get are going to be applied to that sample only, and you cannot immediately extrapolate them, if that makes sense.
Okay. The other thing I wanted to mention is that you've been kind of getting bombarded with questions. So I think for now, let's pause the questions and let's get to the results, and we'll have time to ask questions later.
All right, sounds good. So let me show you the results of the experiment. A few results to mention here. One is that in general, personalized rankings kind of quite dramatically increased how engaged consumers are with the website. People are twice more likely to click on at least some items under personalization. When they click somewhere, they click on 20% more items, and they are 8 or 7.8% more likely to purchase. And what we see is basically that not only people are a lot more engaged with the website, but also they are more likely to buy, which is the first indication for us that they are more efficient in finding something that they really like in responding to these personalized rankings. We also see some indication that the retailer benefits from it. For example, the per user revenues increased by 4.5% in this experiment. And we don't find any evidence, at least in these estimates, that the retailer is steering consumers towards expensive products. So if anything, consumers end up buying cheaper products on average. And so overall, we take this as a first evidence that the incentives here tend to be very much aligned, and both consumers and retailers benefit. But I'll tell you more about this later, of course, once we show you the exact welfare numbers. Now, if you want to think about what happens at the aggregate level, and this is probably my most favorite graph of the paper, what you're looking at here is the distribution of market shares across products. We ordered all products here by their popularity in the world without personalization. So more popular products at the left, less popular at the right. And we are plotting the distribution of market shares with and without personalization. And what you see here is basically as we introduce personalization, we shift from the solid line to the dashed line. The curve rotates in a sense that products that were bestsellers or products that were really, really popular lose their market shares pretty dramatically. And then products that were less popular and that were sold much less frequently are increasing their market shares quite a bit. And so you see that this long tail growing. And if this is too abstract, consider some examples. You can look at the products that lose market shares under personalization, and you see a lot of these bets that look very boring, very neutral, extremely standard, standard colors, standard designs. And once you look at the bets that actually gain a lot of popularity and gain market shares, then you see something like this. And like you see a lot of bets that are modern looking, have futuristic designs, unusual styles, unusual colors, and so on and so forth. So it probably takes very specific kind of preference to buy one of these bets. And the question is, we know people with these preferences exist. The question is, well, is the algorithm designed in a way that discovers these people, learns their preferences, and shows them these niche items, how efficient the algorithm is at doing that, and is that good for consumers in the end or not? Okay, and so let me show you the first part of the model that might actually answer quite a few questions from before as well, and then I'll make another pause for questions there. So okay, so at this point you might be thinking, why do these guys need a model in the first place? So I want you to be thinking about two main things we are doing with it. One is we are trying to distinguish the true tastes of people from position effects, right? This idea that did you click on something because you really liked it, or did you click on it because I showed that item to you? We're going to do that by estimating position effects from the holdout data where rankings are not personalized. And so by design of that algorithm in Wayfair's model, conditional on a product identity, whether the product appears at different positions is going to be coming from a random variation. Okay, and so it's always, the list is always ordered according to product popularity, but conditional on that popularity, Wayfair adds some randomization, and we're going to use it to estimate position effects. We're going to take those estimated position effects and basically extrapolate them to the personalized sample. And two, we're going to be basically thinking how to recover consumer tastes, because the main part of our model tries to estimate consumer surplus with and without personalization. We're going to recover tastes from two data sets, from data on clicks, or what is it that you searched and what are the attributes of products that you searched, and the data on your personalized rankings. Once we do that, we're going to essentially ask a question of, well, I showed you some set of items, right? That was your personalized ranking. Now, given my estimate of your preferences, was there some other item outside of that set that I could have shown you that would have been much better for you in terms of utility? And if the answer is yes, then the ranking is not doing a very good job steering consumers towards good products. But if the answer is no, then the rankings are actually going to generate quite a bit of consumer surplus. Okay, so that's what the model is for. Now the model is actually quite simple. So let me present the consumer side of this model first. The consumer is going to go to the category of bets and is going to look at the products, say on the first page of that category page. So think about that set of products as JI. For each of these products, consumer sees some basic attributes of products as well as prices. So he's going to formulate what we call click utility, UIJ. That click utility is going to be equal to xj times beta I, which here is just kind of a simple random coefficient formulation. Think about xj as standard attributes of products, material, color, all of that stuff, minus alpha I times price of a product. So alpha I is price sensitivity of that user, plus, and that's the novel part here, xi j times theta I. And so why do we need that part here? Well, basically the main reason is we are looking at the market with a lot of highly differentiated products, right? There are going to be 700-800 products in our data sample. And it's very difficult to describe people's preferences for all of these items with kind of just a handful of observed attributes that we actually see in the data. And so what we want to achieve with that part of the model is to introduce the concept of latent attributes. Now that's xij, that's going to be observed to consumers, but not to researchers, not to us. Okay, and so we're going to assume that people are thinking about some attributes like that. They differ in the way they care about these attributes, which is going to be this theta I preference. And you can basically think about this part of the utility as the same as the first part, except xij are not observed. Okay, and that kind of goes back to the idea that my co-author Rob Donnelly and Susan Athey used in that paper in the context of full information demand models. And so we are importing that idea to the world of search models and consideration models. Okay, so that's the click utility. That's going to be minus gamma Rij. Gamma is the position effect. Rij is the position at which item J is shown to user I. Here, the position effects are linear. In the paper, they're actually non-linear, but here I'm just simplifying presentation, plus the random normal shock eta ij. Now, that's the stage at which you are deciding what you want to click on once I showed you rankings. Once you clicked on several items, you have your quote-unquote consideration set. How do you decide where to click? Well, our simple model is you decide to click on something if its click utility is above 0. Okay, that's going to be an independent decision for each product. It's a very simplified model, but we chose this model because it allows us to kind of capture all the interesting aspects of this problem. We can model pretty rich taste heterogeneity. We can capture position effects and separate them from tastes. And the model, and that's key here, the model is still scalable so that we can estimate it on our sample of 1 million users. Okay, and so that's actually in the way we write it, it's very similar to the model of Michel Savinsky-Goyre of 2008. Okay, so once you click on certain items, you're looking at your consideration set. Within that consideration set, you're going to compute something we call UIJ purchase, which is a purchase utility. It's going to be the same as before, so this part is unchanged. But there are two differences. One is there are no position effects. So we're going to assume that what position the product is in is going to affect your decision only through the quote-unquote salience of the product. So you're going to be more likely to click on it, but it's not going to change your belief about the utility that that product generates. And two, there is this new bit, which is psi-j, and it captures all the new information that you learned from opening the product page that you have not anticipated before, that you did not anticipate at this stage of the choice. Okay, so that's the consumer side of it. The retailer side of it is going to be modeled as follows. And here, remember, we need the retailer side of the model because we want to think about estimating position effects, and we want to also come up with an efficient way to extract information about preferences from personalized rankings, kind of accounting for the fact that consumer utility is not the only thing retailer is thinking about when choosing these rankings in the first place. And so this is how we model it. In the holdout group, we're going to assume that the retailer is sorting all products by so-called rank utilities, Uij rank, which are going to be equal to the product fixed effects delta J. That's just capturing historical popularity of items, plus Wij tau, which W here is the indicator that the item is currently sponsored or new. So these items just get bumped to the top sometimes by exogenous reasons, plus random disturbance μij. And so here, just to emphasize, as in the way this algorithm was designed, conditional historical popularity of items, there's going to be some random variation in rankings. And the idea of this equation is that we are isolating that variation and using it to recover position effects. Okay, so that's the holdout group. Remember, this is the experiment, so the holdout group are 5% of randomly assigned users. The rest of the users are randomly assigned to the personalized group, where they see rankings that are built in the following way. The retailer also going to sort all items by Uij rank, the ranking utility. But that ranking utility is now going to look differently. In particular, think about here, at this point, think about, the two-sided nature of this model. On one side, you have consumers who are trying to basically reach the certain part of the product space. They're trying to find products with certain attributes, and what they like is determined by beta I, alpha I, and psi j. Beta I, alpha I, and theta I. Now, on the other side of this model, we're going to have the retailer who is also trying to steer consumers towards the certain part of the product space, but he's going to put different weights on different attributes: beta I tilde, alpha I tilde, theta I tilde. Now, in the world where retailer is just trying to find you what you're looking for, or trying to help you find what you're looking for, or trying to maximize your utility, those weights would be identical to the weights of consumers, assuming the retailer has a good idea about your preferences. Now, they might not be the same, and in this part of the model, we introduce this concept that these weights that the retailer puts on different attributes might be correlated with true preferences, but they might not be the same. And we're going to measure to what extent they are correlated empirically from the data. Why are they not correlated? Well, because retailer cares about other things. Products may have different profitability or different markups, and he might want to put more weight on the attributes that those products have. There might be other reasons as well, but basically this is our generic way of capturing retailers' incentives and trying to reverse engineer the objective function that the retailer is pursuing here. All right. And so let me show you how we model the correlation, and then I'll take some questions. So the idea is, let's organize the type of the consumer, lambda I, as the true preferences of that consumer. Let's assume that the retailer is thinking about those preferences, but he's going to put a different weight on the same attributes, alpha I tilde, beta I tilde, and theta I tilde. We're going to call that lambda I tilde, the vector of those incentives. And we're going to assume that the weights the retailer puts on the attributes are going to be equal to the true consumer's preferences plus some deviation. And that deviation is the most interesting object here. And we're going to make two parametric assumptions. One is going to be on the distribution of true preferences. And so this is very standard. We just assume the standard random coefficient structure on the true preferences. So that's the first part of this equation. The second part of this equation is we assume that the deviations also have some distribution. And so the way to think about this is, if I'm a retailer and I deviate from utility maximizing rankings, say, I know you people have high preference for wooden beds, but I'm going to show them metal beds because they bring me much higher markups, that's going to show up in the mean of those deviations, in the estimated mean of those deviations. Okay? So that's how we parameterize that. And by estimating the distribution of these deviations, we are implicitly estimating how aligned the retailer incentives are with the goal of maximizing consumer utility. Okay, so let me pause here and see if there are any questions about the model. We have plenty of time left. Yes, Chris.
Hi, this is great. I really like what you've done here on this slide. My question is actually on the consumer choice side. So can you verify, I just want to make sure I have this right. Can you verify that, like, as a consumer is scrolling through beds and clicking on certain, pictures of beds that she likes, that doesn't impact kind of future beds that she may or may not click on? So it's like independent decision of whether or not she kind of clicks going down, and other than the fact that it's a function of the position bias. Is that right?
That's right. So this is
Okay.
very simple way to capture search. Your decisions for different bets are going to be independent.
Do you have data to support that by any chance? I'm just curious if there was a way that either you or Wayfair had looked at that and kind of come up with that assumption, or if it's more for tractability, which is fine.
Yeah. So So take a step back. Our general strategy here is to write down a model simple enough that allows us to have all the interesting things that I kind of outlined, all the latent attributes, the heterogeneity, scalability, and all of that. We're certainly losing something by not assuming, a kind of a full-blown search model, but that's not quite our goal here, if that makes sense. We have not, answering your specific question, we have not tested the independence assumption explicitly, but I'd be curious to know if you think we can test it, so we can chat about it more.
Thanks.
Yes, Panin?
Am I right? There's no search cost? And how should we think about consumer welfare related to that?
Right. So you should think about consumer welfare as we have a model which is going to tell us how people trade off money and attributes. It's a pretty standard logic in discrete choice models. Here it's a bit different because of the consideration layer. It's not quite full information model, but the logic is very similar. So that tells us how much people are willing to pay for products with different combinations of attributes, and that's what goes into the welfare computations. Now, you're right that there is also a search component that you might want to think about. In particular, you might be curious, with personalization, is it the case that people are finding products that they're looking for quicker, and so the search costs are now lower in total? That's not something we can quantify with this model, unfortunately, but I think it would be very interesting to try to quantify something like that. But I don't think the right way to characterize our model is people don't have search costs. I mean, you can think about this equation, and you can think about rewriting it as the click utility is above certain threshold, where that threshold is your quote unquote search costs. It's going to be equivalent to our model. So we have 0 here without loss of generality. And once you estimate that constant in that equation, you can actually roughly interpret it as search costs. We have not tried to do that yet.
I guess for the welfare analysis, I would also be worried about, given that the evidence from the experiment that you showed us was that people are searching more, right? And so if there are costs associated with that, I would also be worried about the opposite of the bias that you were describing before.
Yeah, I can definitely see how you would be worried about it. I think we should not worry much about it. And the reason is that we see two things happening in the experiment. One is we think we have two things happening in our sample in general. One is people are very unlikely to buy something. Most of people live without buying, which means when you start your search, you don't have much hope for finding something you like on average, right? But at the same time, people search quite a bit and they click on a lot of items and they spend quite a bit of time on the website. And what it tells you is probably search costs are not very high, or at least we have not quantified them yet, but my speculation here would be probably search costs are not very high and they are unlikely to drive the welfare numbers here. Yes, Andrei?
Yeah, just a quick question about the firm side here. Is there any potential issues that might happen if the firm is observing something that you don't observe? And here I'm thinking maybe they're using a neural network to classify images or something, and that goes into this. And so maybe the misalignment is actually due to different information sets.
Right. So if they let's see, if they know something that we don't know, and that happens to be a more precise estimate of consumer preferences than what we have, that's actually great for us because we are going to take that equation. We're going to say, well, it looks like they're getting it right in the sense that they're showing the right people, right products to the right people, and people react by clicking there and buying it. And so that's going to be, the information that we are extracting from personalized rankings. So kind of what you pointed out is exactly the case that we would like to have in order to learn efficiently from personalized rankings. Yes, Kevin?
I think actually my point was going to be the same as Andres, but slightly different now. I'm confusing myself. Is some asymmetry that could be present here is you have a short time period of your data and you have to drop a lot, right? Like you only see 10% of the products actually sold. So could there be misalignments simply based on like the sampling issues that you have to confront that Wayfair may not need to or have addressed because their demand estimates incorporate a lot more, right? At least in terms of transactions and whatnot. But I'm not sure. So that would help you in the same way. That's where I'm struggling.
Yeah, I'm not 100% sure, to be honest. Yeah, I'll need to think about that one and how product selection affects this.
I mean, one thing, can you get like some sort of cost data from them? I think that would help. The next slide that you showed us about the misalignment, maybe you can infer something about their strategies if you had their estimates of costs.
That would be amazing. So let me give you kind of a short answer to that, and then we can discuss the long answer once I go through the results. We would love to get cost data. We're thinking about asking them something along the lines of markups from different products. It's obviously going to be hard to get that data, but maybe in some anonymized way, we might be able to get it and correlate it with the incentives of retailers we get from this model. That would be super interesting, but I can tell you more about it because it's not as simple as it looks. And so with that in mind, let me show you.
Also ask for return.
Yeah, go ahead.
I think the return data you should also ask for, because that would be like a validation on the demand side and Fanion's point about, consumer costs and maybe making mistakes, etc.
Absolutely, yes. A good signal of the true utility they extracted from the product. So let's see how we're doing with that. We're actually good with time. Okay. So let me show you two results here. One is, we have estimated the model. This is all going to be based on the model. One result goes along the lines of the graph I showed you a little bit earlier. And that graph showed you that under personalization, we see a long tail of products emerging and a lot less concentrated distribution of sales. We see that happening on average in the model as well. We see that all our concentration indexes that we computed, HHI for clicks, purchases, revenues, drop by a factor of 2 to 3. And we see that if you look at all the items that are outside the top 50 most purchased items in the world without personalization, those items only absorb something like 11% of all purchases when there's no personalization, but under personalization, they get over 45% market share. So there is a big change in concentration here. There's a big growth in this kind of the long tail of products that people were not buying before, and now all of a sudden they can discover them. Now, is any of this good for consumers? So this is the question we wanted to answer. Turns out that yes, it is good for consumers. We find that according to our estimates, the preferences or rather the incentives of the retailer and the consumers are highly aligned. We find that on average, if we look at the correlation across attributes, on average, that correlation is 0.5. So think about that as the retailer is mostly a friendly guide to your search, and he's guiding you in the right direction. But occasionally he deviates and he shows you products that he would like to sell. But on the range between caring 100% about consumers and only optimizing profits, he's somewhere halfway. Two, the average consumer increases their surplus by 30% under personalization. So this is a pretty large effect. And so as we're thinking about where that effect is coming from, I want to show you two decompositions. One is showing the fact that most of this effect is coming from users who were already buying something in the world without personalization, but now they're buying a much better item. So now they are buying an item that matches their preferences much better. Okay, so that's the 2/3 of the welfare effect we see. And only 1/3 of the welfare effect we see is coming from the fact that some users were not buying anything before. They could not find something they like, but under personalization, they actually find something they like and they are converted into purchasers. Now, the second decomposition here has to do with the Anderson's conjecture I previewed in the very beginning, right? Remember, Chris Anderson was thinking that personalization is great because it finds consumers with quote unquote niche preferences, and it tries to match them to products that satisfy those preferences very well. Now, so what we did here is we defined niche items as basically the items that some consumers really liked, but other consumers were indifferent or they basically hated those items, right? So according to that definition, niche items are those that are loved by some consumers and hated by others. We then defined people with quote unquote niche preferences as people who mostly like niche products. And we have more precise definitions in the paper, but that's the intuition. And we then defined niche matches, quote unquote, as the instances where a person with niche preferences is matched with a niche item. And what we see is that, while the total effect on welfare on average is 30%, most of that effect, in fact, over half of that effect, is coming from the fact that now we see a lot more niche matches. So under personalization, people with fairly unusual preferences can now more effectively find something that they really like. Okay. Now we also have some what we call back of the envelope calculations, trying to understand what is personalization likely to do in the long term. And here, kind of the exercise we came up with is we are trying to shut down personalization and we're trying to reconstruct what the assortment Wayfair is offering would have looked like without personalization. So we have an exercise where when we were trying to recover a fixed cost that the Wayfair is paying for having different items in its assortment, we're then trying to kind of recover these costs. Imagine that Wayfair cannot personalize and kind of let Wayfair follow a quote unquote myopic rule where they add products to their assortment one by one until the marginal revenue from adding a product falls short of the cost that they have to pay for adding that product to an assortment. And you can see a lot more details about that in the paper, but what we get out of it is the prediction that without personalization, Wayfair would have offered only 180 products out of the 750 items that they're offering right now. Or in other words, according to these computations, personalized rankings actually allow Wayfair to offer a 4 times larger assortment. Okay, so we're almost out of time, so let me briefly summarize. We find that in general, personalization affected consumer choices quite a bit. It made consumers more active, they click more, they buy more, they buy a much larger variety of products. So there's a growing long tail effect there. There's a growing long tail there, so which we call long tail effect. We find that it benefits both consumers and the retailer. The retailer benefits because now there are a lot more transactions on the website. The consumer benefits mostly because people with relatively niche preferences can now find something that they are looking for, and much more efficiently than they could have done without personalization. And finally, we showed you some preliminary evidence that without personalization, Wayfair would not be able to offer these large assortments in the first place. I will stop here. Thank you for your attention.
Thank you.
Right. Go ahead, Relika.
Yeah, there are a few more questions. June here, do you want to unmute? And I don't know, actually, I don't know if we promoted you. Sorry. I guess I had while I do this, I had a follow-up question. There was Chris was asking about this independence assumption on clicks. I guess you could look at whether the order in which people click these things whether you can explain that, and that would point against, I guess, independence, or any of, I guess, the Weizmann search rules. If you could test those.
How would you test those? I'm very curious. What does it mean to test whether you can explain a search order, I guess?
Yeah, whether do people click on the fifth ranked thing first and then on the first one, or do they always go in the order or something like that?
Right.
Like, do they pick their own order, or is it that would be one guess, but you can think of other ones.
Yeah, no, that's interesting. That's definitely something we should be able to do.
Another thing you can do is just look at, like, from the data, perhaps, like the probability that somebody clicks on a product greater than or equal to rank, say 20 or 30, given that they clicked on something in the first 10 ranks, something like this, to just like a sanity check, because if it's much more likely that they're clicking on products later on, if they click on an earlier product, it might mean they see it more if you don't have scrolling data. There's issues with that logic too, but just to try to get around with it.
Just a quick follow-up on this thought. There are a couple of papers about learning while searching, like Charles Hodson and Greg Lewis, I think, have one.
We're familiar with those papers, yeah.
Yeah, and they might have tests for this type of behavior.
Yeah, that's interesting. That's something we could look at. I mean, I understand where you're coming from with these questions, but another thing to keep in mind is if we do realize that we need some sort of a dynamic search rule here, if that's something we really want to have in a larger model, it's actually hard to think about a search model that would rationalize all the results of our experiment. And the reason for that is we see that people are a lot more likely to buy something as a result of the personalization, which means on average they are seeing probably higher utility items in front of them. But at the same time, any optimal search rule, unless there's some sort of sophisticated learning happening, would say that if you are seeing better items, then you will be much quicker at finding what you're looking for. And so on average, you should, in equilibrium, see less search. And we see more search as a result of our experiment. So it's not even trivial how you would rationalize that.
That's why the search cost, I guess, is really important. Like, is it maybe the search cost is negative? Like, maybe people just like searching. In your case, there's this window shop. I mean, that's how I've gone to Wayfair. It's just they show like 50 products on the page. I mean, it's just fun to look at them. So it might not be exactly the Weizmann model, but it might still be a search model.
But even that model would be pretty sophisticated, right? Because you can you should kind of assume, well, yeah, they search recreationally, but then they get tired over time, so their search costs become negative at some point. So even, we thought about that model, and I think that's a very interesting kind of class of models to think about. But what I would say is it's not obvious how you would even write that.
So Ilya, if you go down this path, and I'm not saying you need to, I think this is great work, definitely check out, I know you're aware of my paper with Wayfair on their event ranking pages. Check it out, because it actually is the opposite effect than like a Weizmann model is saying, look, if you find something that you like, you're going to keep searching more, because it is, like Raluca said, like it's hedonic browsing, right? So like you're modeling a different type of a search behavior than I'm looking for something in particular. When it's category pages of beds, I'm not sure if that fits as well, but we're thinking about.
Yeah, no, definitely.
A slightly different angle. Okay, but it's a great honor to be promoted to panelist. A slightly different angle is like how much the degree of this personalized ranking is generalizable, like the implication. So do you know, do you have a sense that whether this personalized ranking algorithm is kind of standard in the industry or something like that? Because I think it's the whole sort of story of the paper seems to be depending crucially on how they're implementing that, but you are not talking much about the details. What is going on inside?
Right? Yeah, so definitely external validity is something we spend a lot of time thinking about here. I mean, let me put it this way. So we are trying to look at one example of a fairly typical industry with kind of a large number of highly differentiated goods. We are trying to look at an algorithm that's based on the collaborative filtering class of algorithms, which are used everywhere now. Let me put it this way. So we're trying to look at the algorithm that's kind of a modified version of collaborative filtering, which is used everywhere. And so to the extent that this this context is fairly general, we do expect some external validity. Now, of course, all of this is speculation, and ultimately the truly right way to know whether we are right or not is to actually test this hypothesis and to understand whether you can apply our method to other retailers, other product categories, and document this more broadly. And that would
like relatedly, are they I wonder whether Wayfair is like outsourcing their personalized search ranking algorithms to some company. If that's the case, then at least like you can say something about that, right? A little more concerning about like the entire sort of like model is like the whether all those parameters, in particular the latent parameters, are identified, and from what variation those parameters are identified, right? So in particular, the thetas, right? Thetas were a bit concerning here. From what variation in data that identifies theta I? It's not like a fixed effect, right? That you difference out.
So let me put it this way, just to clarify a few things here. So theta and beta I here, they are not separately identified from each other. And we are fine with that. And why is that? Well, because you can have some latent attributes that are correlated with the attributes you do see, and people have different preferences, and you're not going to distinguish them from each other. So the different parts of that structure are not separately identified, and that's fine with us. What we can actually identify is a more general object, which is the correlation between utilities of different products. So what do I mean by that? What I mean by that is if you look at two products, say two beds or two sofas, and you're seeing that these sofas tend to be clicked by this clicked together by the same consumers, right? The same kind of people are clicking on them. Then you conclude that there must be something similar about those sofas that make them look substitutes for some consumers. Now, what does it mean? That means in this model that either you will explain that through these sofas have similar access and some people care about it, or if you cannot explain it with these observed attributes, you'll say, there is something about those sofas, the xij. I don't know what it is, but I know people care about it. And that's how I'm going to justify the fact that those two sofas are perceived as substitutes. Now, you will not know whether that's coming from kind of xijs or xjs and what the exact interpretation is. What you will know is that those utilities are highly correlated.
Even okay, so let me put it this way: even the random coefficients beta i's and alpha i's, right? They're not very well identified, I'd say, right? Separate from the functional form assumption on the epsilons, right? And then now you're inserting one more latent parameter. And then you're claiming that you're sort of like jointly identified, not separately, but jointly identifying the distribution of beta I and theta I, right? But still, it's like a little too opaque to me.
So that's the right statement here is not that we are identifying theta i's or beta i's or some combination. The right statement is we can identify the correlations of utilities, the correlation of utility of one sofa with the correlation of utility of another sofa. So think about the matrix that determines how utilities are correlated, and we are identifying the covariances in that matrix. How we're identifying them from two types of variation. One is the one I described, right? It's two sofas are clicked by the same people. The second one is if two sofas are located close to each other in personalized rankings, that are either both at the top or they are nowhere inside, then that's another indication of that the utilities of two products are correlated. Now, to your other question about the prices, price here is different because prices change over time, and that's the only attribute here that's going to change over time. And so price coefficient is actually identified from that variation rather than from the two types of variation I described.
Are alphas and beta plus theta are allowed to be correlated?
We don't know, but in principle, you can have them correlated. You can
I'll have to think about that a little more. Right?
Correlated here, yeah.
Right, okay, yeah, I'll have to think about that a little more, but still, yeah, identification arguments seems to be a little opaque to me. Yeah, but maybe I'm just not understanding well enough. Yeah.
Ilya, can I ask two kind of more like a bit broader questions? One is related to our previous discussion, also to question from Junhui on what we can how we can interpret the results. I wonder if actually on this slide which you're showing now, you take this approach of assuming there is some correlation in how companies rank and how people rank by utility, and then putting everything else in like normal distribution, everything else is parametric noise. I wonder if you could try to learn something about this algorithm, like how do firms systematically put higher markup, products higher? Like I know you don't see the cost, but maybe under some assumptions you can try to infer something systematic, because this way we can interpret the results and we can really understand how it's done. That's one. And then a second one, this is related to previous discussion from Chris and Raluca and others. I wonder how big of a role it plays here that we assume that the same utility comes into my search decision and my purchase decision. Because in search, in Weifman, for example, I'll also search for products with higher variance of the unobserved shocks, because I want to kind of remove that kind of take the benefit of like products which happen to be very high match value. And this way, again, this now can propagate in what you rank as the firm, because I search for an orange bad just because maybe I like it. And now you think, well, I like it, even though it was just a very high variance product for me. And now I'll end up purchasing that just not because I like it, but because it didn't show me anything else. So I wonder if by testing this, you can somehow relax this assumption or test this assumption, if it makes sense.
Yeah, so to the first question, I mean, we would definitely love to get something about cost data. We might get something along the lines of anonymized data on cost, where we don't know exactly the markups that they're earning from different products, but we kind of know for what type of products markups are higher. And that, as you said, that would be super interesting to kind of start adding something like that in the model and seeing and drawing more general conclusions. So one story there, one hypothesis to test would be, okay, all these algorithms, and not only Wayfair's algorithm, have a tendency to steer people towards niche products. Well, our niche products tend to be, are those products tend to be high markup or not? Are they bringing higher markups than a more popular bestsellers? And that would be one thing to test, and with the cost data, we might be able to do that. But then again, can we get that data? I'm not sure. Hopefully, yes, but it remains to be seen. On your second question, that's really interesting. So it's not just to clarify, it's not the case that those utilities are exactly the same at the click stage and the purchase stage, because we are allowing for new information that is revealed to you on the product page. That information is captured by this, well, here they are product fixed effects, but it can be a more general object. But yes, you're right that what we're missing is that discussion of the variance of the shocks from which you, let's see, the variance of the distribution from which you kind of draw that information. So that's something we cannot look at with this model. But it would be interesting to explore what that does to, say, an optimal ranking rule from the perspective of the retailer.
Can I ask a follow-up question on that? So in this literature, people model different stages of clicks. So some people condition on whether you click, some people condition on whether this was observed in the search list or not. So here you are modeling both jointly, but I'm just curious, how much would you really lose if you didn't model the click decision, if you directly modeled the purchase decision from the entire search list? And that's kind of like point one. And then point two, it does seem like these I forget what term you were using, the surprise conditional on click. That seems like a really interesting and important part of all this, because because something can look very attractive in the search list, but once you click on it, you see like a disqualifying feature, and it would be good to have some counterfactuals about what the role of that shock is. Yeah.
So regarding, regarding click versus purchase data, unfortunately, with purchase data, you would not go that far, because you need a way to estimate preference heterogeneity, and this is a durable product, so you don't see repeat purchases. And so one thing that really helps here is we do actually see multiple clicks of each user, which is kind of a small panel. And so with the search model, or with kind of this general consideration set structure, we can start learning from that data. So that's to your first question. To your second question, yes, I think that's part of the model is really interesting. In fact, if you looked at the earlier drafts of the paper, we actually heavily focused on, describing the fact that there are a lot of products that are what we call hidden gems on the platform, which don't look like much, but once people start clicking on them, they are very likely to buy them. So it means there's something hidden about them that people really like. And there are a lot of other products that are something we call clickbait, which is people are very likely to click on them, but then once they click on them, they realize those products are not very good. We did not kind of focus on that heavily in this version of the draft because there were a lot of other things happening in the model. But in general, we think that accounting for these surprise utilities or kind of maybe even modeling that surprise information in a more structural way is a very interesting venue for research.
And just to follow up on that, like people will oftentimes assume rational expectations here. And does your model have implications for rational expectations over that surprise, or is it separately estimated so that you can actually show that people don't have rational expectations?
So by assumption here in our specific model, psi here is something that you do not anticipate. So that's kind of the residual. That's a completely new information to you. So answering your specific question, yes, that there's no assumption of rational expectations.
I guess like, is the expectation of that surprise 0 or not? I think that maybe that's all I'm asking.
Yeah, I think if you had a more sophisticated model of sequential search, you could have some interesting implications here, because like my expectation over like positive variance of surprises is actually good for me in terms of when I decide to click on marginal things. But I think in our model where they're completely independent, I think there's a lot less going on there, at least that we've thought through so far.
Yeah.
Okay, yeah, that makes sense. Thanks.
Raluca, you had a question, right?
Yeah, I mean, so it's also related to this surprise term. I understand that you're trying to go with kind of the simplest model possible, but there are some important, like this surprise element just comes really out of nowhere. But the consumer does observe a lot of information about those products before clicking, and they might be able to have an expectation of whether or not they will, like whether or not they have a lot of uncertainty or they kind of know this product very well. So I'm just, again, I know you want to go with the simplest model, but there's some value also of capturing this in some more structural way. And maybe it's just a robustness check. I don't know, but
Yeah.
Seems like there are a lot of models in the literature that account for this additional information that people get in a second stage of search. So, it's possible to do it.
Right. No, it's definitely possible to do it. For us, it'd be like we thought about these models. In fact, I think when we started writing this paper, we had something along the lines of a sequential search model here, and we shift to something easier just because there was no way to make that model complex enough to generate plausible welfare numbers, if that makes sense. And so, yeah, you're right. I mean, there is a lot of value in thinking how to account for that more structurally. We have not figured out a good way to do that yet. Chris?
Thanks, Ilya. This was great. Yeah, just one more comment on the end. I thought it was interesting you said, personalized rankings makes it possible for a Wayfair to kind of offer more products, or for the retailer offer more products. I see it slightly differently and maybe even more powerfully. So I think, one really easy way to offer more products is just to give random, like kind of stupid, naive rankings. Then you offer tons of products, right? If everyone just sees a different random subset of the full product catalog. So in that sense, you would be maximizing the total kind of diversity of products that you're showing. Now that obviously is going to lead to worse off consumer welfare, worse off for the retailer, kind of worse off across the board. And so I think that's why a lot of retailers move to the popularity-based ranking, or what you're calling non-personalized ranking, because you can kind of increase your overall benefit to consumers and to the retailers by doing so. But I think what you've uncovered here is more like going away from the popularity ranking and saying, look, the personalized ranking, in Wayfair's case, this particular algorithm is a way that they've identified to be smarter than random rankings, but to still introduce kind of diversity or expand the number of products that they're offering. And at the same time, make it better off for the consumers and for the retailers, which I think is a really cool kind of finding that you have here. Yeah, so in any case, this final 2 cents, but I thought this work was great. I really enjoyed your talk.
I could not have summarized it better myself. So it's, yeah, that's a very good way to view it.
Cool, thanks. And thanks everyone for inviting me to participate. This was a fun seminar.
Yeah, thanks
Thank
for
you.
participating.
Bye, yeah.
Thank you, Chris, and thank you, Ilya, for a great talk.
Thanks a lot for inviting me and organizing. This was great.